we are part of the problem. And that is one of the things that in software development, people don't think that we are part of the problem, but we are part of the solution because we have so big handprint as an industry that we reduce the emissions of the analogical industries with digital. But then we create a lot of digital emissions.
Welcome to the Agile Digital Transformation Podcast, where we explore different aspects of digital transformation and digital experience with your host, Tim Butera, Content and Community Manager at AgileDrop.
Hello, everyone. Thanks for tuning in. Our guest today is Janne Kalliola, founder and chief growth officer of the digital services agency Exove. He's recently published a book about green coding, and this is what we'll be discussing today. So the environmental impact of technology and how green coding practices can help here. Janne, welcome to the show. Thanks so much for being our guest. Do you want to add anything here, or should we just jump straight to our questions?
Thanks. Nothing to add. That was a very good intro. So let's start with the questions.
Awesome. The first thing that I want to talk about today is this double-edged sword of data and innovation. You know, we usually treat new data-driven technologies as kind of the be-all, end-all, ultimate solutions without really considering potential long-term downsides enough and stuff like environmental impact.
Mm-hmm.
So, for example, you know, if we compare something like IoT, so the Internet of Things on the one hand, and something like the metaverse on the other, both of these are super data intensive, but they have widely different implications for society and the future of humanity, right? What are your thoughts here?
True. Yes. If we start from the sort of environmental impacts, I don't talk anything about the sort of related to society and so forth. That's a topic for somebody else that is better knows those topics than I do, because the metaverse, for example, has also other impacts than just the environmental. But environmental sense, there's probably everybody knows already now the concept of carbon footprint, that how much carbon emissions your service creates. Then there's also a concept of carbon handprint. That means that how much your service or the thing that you are doing is removing carbon from the carbon emissions. So if you have, let's say, an IoT is used in a steel mill, and then you can optimize the performance of the steel mill, and you can reduce the amount of energy used to heat the steel, for example, you will have a huge carbon handprint because you just reduce the emissions. So the IoT has a lot of these kind of possibilities to create better world by reducing inefficiencies, removing bottlenecks and whatnot in industrial processes. And then the amount of emissions, IoT sensors, the logistics, the creation of the sensors, the logistics and everything, and the software and the data that we then probably you store for long periods of time and analyze it for the longer trends and whatnot, that has a huge positive impact. On the other hand, then discussing about metaverse or the cryptocurrencies, they will use a huge amount of data and then also huge amount of transmission capacity for achieving something that most probably doesn't really bring that kind of huge energy savings, and in some cases might be just completely pointless as a like a solution that is looking for a problem. So they don't add up anything. Or of course, that I and you, if we would meet in metaverse, we would not need to travel. Mm-hmm. On the other hand, whether the immersiveness of the metaverse would be better or way better than the call that we have now in Zoom, most probably not. That meeting together as avatars in some 3D space, that at least I would be nauseous, most probably won't really change the experience so much that it would make sense. And then, for example, the cryptocurrencies, it's really good for drug dealers and people that want to want to sort of get financial gains by speculation. And then for the rest of the planet, most probably the impact is completely negative.
I think another important distinction to make is also the difference in environmental impact between software versus hardware, right? Because we already kind of alluded to this with the talk about IoT. So yeah, what would you say here?
There's like two different things there. There's the cycle of the speed of how quickly we sort of purchase new devices. How quick is the cycle of renewing stuff, and that has been mostly driven by marketing. So it's the best of Apple, Samsung, Google, and the others that manufacture the phones and the other devices, that people buy new devices, and they have created a lust. Most of the capitalism is run with that somebody creates a desire and then fulfills the desire, and the devices typically would be usable for way longer period. But when there are new, more powerful devices, then the software easily eats. It's like a bureaucracy that it will always grow and it will always sort of fill all the available space.
Mm-hmm.
So the software demand will grow, and then you can't run the older. You can't run the new software on an older device because it's not performing that well. But funnily enough, when you look at you look at the people, that we are still the same people that we were on the Stone Age. We are not any faster. We don't process things any faster, and we were sort of satisfied in the 80s with the I was grown up with the Commodore machines and VIC-20, Commodore 16, and then Amiga. And Amiga was the first device that was actually, I could perform a lot of things that I still do. Write text, make drawings, and these kind of things. Of course, it's not the perfect one, but it's like 10,000 times slower machine than my mobile phone. And I still do the same kind of things. I play games, I read emails, so forth. But the software is so bloated that we need to have faster devices.
Mm-hmm.
And then the other area is this, that the people don't really think in that how much the device manufacturing, the logistics, getting the device to the right place, the right hand, maybe some configurations, reinstalling everything to new device, that what is the environmental impact of that. And then when we have more data, we have more stuff to process, we have better screens, we have better cameras on the phones, but our eyes are still the same. And after like 300 dpi to 600 dpi, that's something that I used to study back in the days in the late 90s. I studied some part of the printing technology. So there's somewhere there in the 300, 600 dpi that the people's eyes, they just don't anymore see details. And when you are like me, I'm 50 already, then you just see less and less details, I can assure you. So what's the point of having so densely packed screen that can show so big photographs, because the information that you see as the viewer of the photo is the same even the photo would have like 1/10 of the data. Mm-hmm. Because the information still is the same, because you can't see the details. Sometimes you can zoom in, yes there are certain possibilities, but most of the let's say that you have a family outing and then you take photos. Would you zoom in to see the sort of ear hair or the pimples on the faces or what? What would be the reason to zoom in? There is no practical reason. Then of course, if there's a photo of a stadium full of people and you want to see that, yes, I'm here, I'm at that group of pixels looking at the band that's playing there, then there might be need. But for most of the photos, It doesn't really matter, but it just increased at 50 megapixel photos. And after like four or six, I have been happy.
So it's on both sides, it's very complicated, right? You have on the hardware side and kind of the interplay with software. We talked about kind of planned obsolescence versus perceived obsolescence. So planned obsolescence is kind of inevitable because of new, more demanding software requiring hardware changes. And then perceived obsolescence, what you talked about, it being the fault of marketers. I also, this perceived obsolescence thing was also really interesting to me because of, okay, you have like iPhone and you have iPhone, I guess, iPhone 9, and then you had iPhone X, right? It moved by one. But then Huawei, you had Huawei P20, and then the next year P30 came out, and suddenly it looked like you were 10 versions behind, not just one version behind. So yeah, definitely I mean, a lot of things to consider here.
Yeah, and then one thing that I want to add, that if the software, that is one of the points in my book, that if the software would be written with quality fashion and focused on the ecological impact, there would be no need to update the devices. We would be happy with, let's say, 10 years old phones because they would just run fine. But now we waste the performance increases are wasted partially because the software developers are lazy and they use the libraries. They don't really optimize the software because that doesn't matter. It runs faster than the people can think in almost any device. Software developers have always the latest devices, so it's always fast enough for them. And that's one of the reasons why it's so slow with the slower devices, because the people that code them don't really try to use the cheaper old devices and so forth. So we are part of the problem. And that is one of the things that in software development, people don't think that we are part of the problem, but we are part of the solution because we have so big handprint as an industry that we reduce the emissions of the analogical industries with digital. But then we create a lot of digital emissions, or not, of course, they are not digital emissions, but we create emissions because of digital infrastructure. And a lot of that emission could be avoided with better planning and better coding.
That was a very good add-on, yeah. And another thing I'm interested about is cloud computing and how that can help with green or sustainable coding. And especially, I'm wondering if there are any misconceptions here that we should be aware of that we can take this opportunity to debunk and kind of explain here.
Yeah, I would say that the cloud is better than having the hosting on-prem, because then the cloud, because there's so much code happening in cloud, there's so much processing happening, and there's so much data, they can actually optimize and pack the computers as full as possible. So the best utilization for a device is that it runs on optimal speed all the time. That there's always something that if the system waits, of course, it doesn't use that much electricity. But if we have, let's say, we have like 1,000 computers in some hosting center that are used like approximately 60% power, and you can't really change because all of those 60% are used by monolithic software. But in cloud with hypervisors, the software is less, it is sort of smaller in granularity, that they are smaller pieces that you can then load balance. So instead of 1,000 computers, you could get away with 700 computers and still have some buffer in each of the computers and do the exact same computations, but with less hardware used. The caveat with cloud computing is that there is no capital expenses shown to that you don't need to buy anything, any hardware, that I need to buy a new server. But the amount of computing power, amount of data that can be processed is infinite, sort of. And then it's very easy to buy more capacity And that has been made very, very easy by the capacity, and a little bit harder to get rid of the capacity. And typically from the software developer's point of view, somebody else pays the bills of the cloud. So the invoice or the credit card belongs to somebody else. So they might ever see the cost of the operations. And then when the cost is somebody else's problem, then it means that the efficiency is also somebody else's problem. And when the code is not efficient, it creates more emissions by both using more hardware and using more electricity. And then there's probably people listening to this are thinking about that, but they run on green electricity or they are renewable. But still, the amount of electricity used in the world is growing so fast that there are still non-renewable power plants are built. It means that somebody else is using that non-green energy. Especially in Europe, when it's a windy day, there's a lot of energy available and it's very, very clean. But when there's less of that energy available, then the energy is not clean. And if we add more energy consumption by bad software, then we will move and use the green energy to run the software. Then somebody else, somewhere else, is using the unclean energy like coal energy or gas energy. And somebody is still using the energy. Somebody is causing the emissions, even if it's not the IT. So we are fooling ourselves to think that it's not our problem. It's exactly our problem. The energy consumption of the IT is more than the airplane industry, and that's a lot. And they are guilty of all the mishaps of climate change. They are the culprit of everything, scapegoat in a sense. But we are using as much energy as they are, of course, in different form, but still energy, and that causes emissions.
So I guess this is the right place to ask what kind of impact do you think that green coding will have on this whole digitalization, digital transformation movement that we're kind of witnessing right now in full swing?
That is a very, very good question. This is typically prelude to the saying that I don't have an answer. So we are still quite early on that phase. I don't know, probably nobody really knows the impact of the green coding. If the software is really bad, and they have discussed this is anecdotal information, but still has some truth. I have discussed with the cloud service provider that said that the worst 5% of the software uses like 80% of the energy. That it's just that the bad behaving software eats a lot of energy. Of course, this is now in the field of content management systems and web applications. That it's not that kind of hard calculations. That if you have like AI or you are doing a weather modeling or something that is complex, then you typically don't have bad software because the bad software would not get the things done at all. So it's limited the scope. But for example, the cryptocurrencies, there has been that they eat the energy of Argentina or eat the energy of Czech Republic. And that's a lot. That if you have cryptocurrency that is on the nation level of energy consumption, that is like 20th biggest consumer of energy, or the ad networks. There was a study in Finland made that the ad networks, meaning the ads that we see in Google and the websites, that they eat 10% of the energy consumption of the internet. Because every single time there's one ad shown, there's like 100 to 200 auction or computers participating in an auction that happens in milliseconds at who gets the spot. And then you fire that every single time, or 5 times, 10 times when you go to a web page. And probably you and I, we go hundreds of web pages every single day. because we are searching for information or whatnot. And then we multiply that with the amount of people living in first world with the good access to internet. Let's say 1 billion people. There's billions or trillions of ad auctions happening every day, and the value that they add to everybody else except that who runs the auction, they get the best money out of it, is probably really small. And these kind of things boggles my mind, that there is so huge waste of energy in the internet because it's so cheap to run those things, and there's a business incentive built on those. But the sort of the impact of the on the quality of life is very small. As an industry, we should really get our sort of things together and start making changes.
Mm-hmm. And in a lot of cases, I mean, the impact of ads, in a lot of cases, is not just small, but it's non-existent to the individual, or even if we're talking about like emissions and energy consumptions and stuff like that, I kind of can't tie advertising and ads off from kind of this over and hyper production, right? So it's kind of they go hand in hand, right? So because
exactly,
the more ads you have, the more production you have, and the bigger your energy consumption will be, because the ads will make certain things more attractive and more desirable, which otherwise wouldn't even be needed, maybe.
Yeah, that's true. And the ratio that I've seen ads in the internet like 20 years. Back in the 98, 25 years ago, we made our first banner ads to fund a study trip to California from Finland.
Mm-hmm.
So I've been working with the web publishing for quite a long time and seeing the ads. Then it was just the image file on the web page and no fancy stuff, no auction, whatnot. But the times that I've in 25 years I've clicked an ad, not an accident, but just click an ad, is like once a year, twice a year, so maybe 50 times. Let's say 50, and I purchased the product. I've done that. There have been some good ads, but probably 5 products in 25 years. Maybe I've made decisions in the store that I've seen something in the web or whatnot. Maybe not. I can't really say, and I have not followed that. But those things that when I've actually purchased something followed by an ad, it has been really small. I might be a luddite in that sense that I don't really want to buy stuff from the internet, or then I'm not an exception. I can't say I haven't studied that much. But for me, it feels so complete waste of everything. The products, of course, I felt that they have been. I have actually have a need that their products have fulfilled. And yes, it might have been better that instead of that I have traveled around city of Helsinki to look for the product that I'm looking that I'm actually bought from the internet, or then not.
I feel like most ads are not made for people who discuss the negative impacts of ads on podcasts.
Yeah, that's true also. And then was it the same study or the following study? It was made by Lappeenranta University of Technology. Was it 40% of the ads are clicked by people or machines that do that because they want to earn money for the people that host the ads? So there are click farms in China and so forth that it's sort of it's just the layer after layer after layer. The game just becomes more and more bizarre. It's like reading a book, a Kafka book or something like that. That it every turn, no, this won't happen. This doesn't make any sense. It is surreal thing. And then there are huge companies like Facebook and Google or Meta and Alphabet that get them almost all of their money from that system that is completely gamed and waste of many things.
So if business leaders were to make any cuts one of the first things they could look at to reduce their emissions and to kind of be more sustainable, be greener, also in the digital sphere, would be to kind of have more streamlined advertising, maybe somewhere in that area. What are some other things that they should consider first before any other cuts or any other changes? What are the easiest changes to make?
There are like two kind of companies in the world in this sense, that there are the companies that code either for themselves or for somebody else. And then there are the companies that buy code, ready-made code from somebody. So if you are on the latter end, there's the golden rule that who has the gold makes the rules. So if you are buying stuff, then you should insist in the procurement that you want to have carbon-wise, eco-friendly, efficient code, and have some kind of measurements. Maybe get somebody to help you with the making your own procurement criteria and figuring out how to follow those. But if nobody demands the change won't happen.
Mm-hmm.
If you are then on the other side of the fence, that you are either writing code for your own organization, that you have an IT department with the software developers, or you are like Exove is a software consultant company that we code for money. So then it's about the awareness first, that people know that these things actually matter. Then there's the training, that what can be done. There are certain ways that you can change have an impact in a sense with your coding. And then they need to spread the word also, that the evangelize what I'm doing right now to the hopefully some of the podcast listeners will see the light after this one and see that yes, this is the Church of Green Code. This is where I want to belong. So that is important too, because we need to have a change. Mm-hmm. The actual what to do is the answer is what the typical senior would answer to any junior question, that it depends. So it depends on the circumstances. It depends of the kind of the system you are working on and whatnot. There might be that if you are working, for example, image recognition, that kind of artificial vision, or you are working with the crypto contracts, or you are working with AI, or you are working with WordPress or Drupal, all of have different implications and the hotspots. I've seen three generic ways to do it. The first is the typical engineer way, that you measure, and based on the measurements, you will figure out what to change. The problem is that it's extremely hard to measure things. It's extremely hard to measure things in a sort of organized, in a way that it actually makes sense, that you have information about the measurement and not just data. So if you can measure, very good, use that measurements, and then find where the energy is used, or where the time is spent. Because there was a study made by a Portuguese university that there's a strong or very strong correlation between the execution time of software and the energy consumption in all languages that they tried out, with like 20 different languages. So if your software runs faster, it will create less emissions. So that's the first, that you measure, and then you make changes, and then you measure again and see that okay, this was done, and we got some change, and then you measure the new spot and whatnot. Typically, software is so complicated that you can't get reliable measurements. So the next, that what I'm proposing in the book, is reduce waste. So the concept of waste is like in the lean, that the things that do not add value. Mm-hmm. So if there is a subsystem in your software that does not add value, cut it. If there's a software that doesn't add value, then but it's still executing. For example, a system that is monitoring something that doesn't exist anymore, and then sending alerts every 5 seconds that this is broken, nobody cares about the alerts, shut it down. There might be over complex data structures. architecture might be wrong and so forth. There's like, I've recognized 10 to 15 different types of waste, and all of them have different ways to mitigate the issues. And then the third way after the measurements and the waste is minimization, that you do a software that excels in the things, in the sort of features that it needs to excel, and nothing else. Just get rid of everything, because if you have that kind of elegant system that is perfect for a certain use, don't add bells and whistles, new features, because the software industry is also very feature driven. But just stay true to the purpose and keep it simple. A good example that I like to chop wood. My kids don't really like it because they need to be part of it also. It's a good exercise. They will understand when they are 40 or something like that. I'm not really good at that. But I have a really good fish-cast axe that is like a simplification of the axe for like 100 years of continuous improvement. But it's extremely good at chopping wood, but it's not good at, for example, if I would like to build a log house, then I would need to use different axe. So there is not axe that fits all the purposes and have different blades and whatnot, because it would be heavier. But there's a simple tool for simple thing, chopping the wood, and that axe is sort of current perfection of how to chop the wood with axe. And then I use it for that purpose only, and then I have some other tools. So in software world, if there would be a need that I need to chop digital wood, and then I have a software that is a digital axe, that would be fine. But typically in software there would be different blades, and there are all kind of measurements in the axe and whatnot. Because why not? It's cheap to do. Everybody's interested about those, that how fast you chop, what is the angle you chop and whatnot. And most of that doesn't really matter, but it would just consume energy. So back to basics, the crucial things only, because typically those software that do something well, simple things well, they are also the software that people love, that you will have people that follow the software and might use it for years to come because they like the elegance and the simplicity of it. Of course, that you can't have a simple and elegant, let's say, e-bank, because there are so many different things that people want to use e-bank, that somebody just wants to pay bills, somebody goes to handle loans, then there are these stock exchange shares, whatnot. So it goes on and on. But it might be that there are certain issues that you can use minimize software. So 3 things: measurement, waste, and minimization.
That was a really great answer, Janne, and a lot of really great tips for listeners right here at the end. If these listeners would like to reach out to you, learn more about you, maybe check out your book, where can they do all that?
Yeah, the book is available free of charge at exove.com, exove.com. It's available in Finnish. If you don't know Finnish, this is also a good guidebook to learn the language. It's a great language. But for the language restricted people out there, the English version is also available, and it's like word-to-word translation, so it has all the same things. Please download it, because it's crucial that we make a change, and I made a conscious decision that I don't want to have the book published by somebody and get the money out of it, because I want to share the knowledge about these things.
Awesome. We'll make sure to link to Exove's website, and hopefully a lot of listeners right now will also check out the book. Janne, thanks again for joining us today. It was great to have you.
No worries. It's a pleasure to be here.
And to our listeners, that's all for this episode. Have a great day, everyone, and stay safe.
Thanks for tuning in. If you'd like to check out our other episodes, you can find all of them at agiledrop.com/podcast, as well as on all the most popular podcasting platforms. Make sure to subscribe so you don't miss any new episodes, and don't forget to share the podcast with your friends and colleagues.